another paper of Pure Maths P3, May-June 2021, the second variant. Let's look at the first question. The first question is about modulus inequality. Modulus on both sides, square both sides. Therefore, 2x minus 1, the whole thing square is lesser than 3 bracket x plus 1, the whole thing square. This is 4x square minus 4x plus 1 is lesser than 9 multiplied with x square plus 2x plus 1, bracket closed. 4x square minus 4x plus 1 is lesser than 9x square plus 18x plus 9. Transfer everything on the left. 4 minus 9 is minus 5x square. Minus 4 minus 18, that is minus 22x. 1 minus 9 is negative 8 is lesser than 0. Multiply with a positive sign, positive 1. So this is 5x square plus 22x plus 8 is greater than 0. 5 into 8 is 40. 20 into 2 is 40. 5x square plus 20x plus 2x plus 8 is greater than 0. 5x x plus 4 plus 2 x plus 4 greater than 0. X plus 4, 5x plus 2 is greater than 0. Draw a number line, that's the x-axis. Draw a curve, label the roots. The smallest is minus 4 and the largest is minus 2/5. It says greater than 0, that is the region above the x-axis. Two separate region, two separate answer. Therefore, the final answer is as follows: x is lesser than minus 4, x is greater than minus 2/5. So that is the first question solved of this particular paper, that is P3, and this time it is the which variant of P3? This is the second variant of P3. Now let's move on. Let's move to the second question. This is about complex number, and the question says, on a sketch of an Argand diagram, shade the region. So first of all, focus on the Argand diagram. We need a sketch. We need to shade the region, represent the complex number z satisfying the inequalities such and such. First of all, draw the axes. So somewhere here is the x-axis and the y-axis. And what exactly do we need to draw? We need to draw a circle. Z minus 1 plus I, taking this minus 1 common is a must, is less than or equal to 1. Always double check rather than the examiner checking it for you. Minus into minus 1 becomes plus 1. Minus into plus 1 becomes minus 1. It's perfectly right. It's a circle and the center is 1 minus 1 comma 1 and the radius is 1 unit, and we will shade inside that circle. So let me draw it. Somewhere here is minus 1. Somewhere here is I. This is the imaginary axis and this is the real axis, and I need to draw a circle without the shading for right now. So when you draw the circle, make sure that it touches both the axes, because the radius is 1 unit. It has to be realistic. Second thing is, when we talk about this argument z minus 1 plus 0i, that is the thing that you have to take care of. The minus should be common and there should be the real part and the imaginary part for that particular number, the starting point. So therefore, this is lesser than or equal to 3/4 pi. So the starting point is 1, 0 and the angle is 3 pi by 4. So let's label the starting point as 1 comma 0. So this is 1 comma 0. And let me mark this over here. And this is like the x-axis, the launching pad, and 3 pi by 4. So 3 pi by 4 would be this. Let me draw this green line. And it should pass through the center. Why it would be passing? No, not exactly through the center, through this point. Because the angle is 45 degrees, the basic angle. So therefore, the line goes like this. Now it says the angle should be lesser than 3 pi by 4. That means the angle could be 90, the angle could be 70, it could be 45, it could be 0. So therefore, what is the region that you will shade? So the shaded region is this region, that is the small segment at the top. That is what is required. So first double check, have you labeled everything? Imaginary, real, center of the circle. Let me label the center of the circle as this. And this is the starting point. And because of 45 degrees, it will pass through this. And everything is perfect for 4 marks. Next question. This question is about, looks like logs, and maybe it's about linear log. So let's see. So this is logs for sure, logs and indices or exponent. It says variables x and y satisfy this equation. X is equals to a multiplied with 3 raised to power of minus y. Explain why the graph of ln x, y against ln x, is a straight line. State the exact value of the gradient of the line. So basically you have to take log of both sides. So therefore you can either start taking log as it is, or maybe you can transfer the side. It doesn't make a difference as such. So take natural log of both sides. Why natural log? Why ln? Why not lg? Because it says ln. Ln raised x is ln of a multiplied with 3 raised to power of minus y. That is ln of a plus ln 3 raised to power of minus y. This is ln of a, and this is plus minus y goes down, ln 3, and this is equals to ln of x. Change the sides. Y ln 3 is equals to negative ln x, is that so? Plus ln of a. And y equals to 1 over ln 3 multiplied with negative ln x, and this is 1 over ln 3 multiplied with ln of a. Got the idea? Now this is of the form y is equals to m x plus c. This whole thing, let me highlight it. So I should choose a blue color, I can choose a orange color, and I can go with this reddish. So this blue color thing, this and this is your y-intercept. This orange color thing, this is your x, and this purplish thing, this thing and this thing, this is your m. So what is it asking? Find the exact value of the gradient of the line. So therefore, don't forget the minus sign also. So there is this minus sign, and that naturally goes with this. So the gradient is negative. So m equals to negative 1 over ln 3. That is the value of the gradient. Now let's focus over here. It is given that line intersects the y-axis at the point where y is equals to 1.3. Now it's talking about this line. So therefore, let me write this thing again. Y is equals to minus 1 over ln 3. And this is ln x. And this is 1 over ln 3 multiplied with ln of a. So it says it intersects the y-axis. When line intersects y-axis, therefore x coordinate is 0. But over here, the x coordinate is not x as such. So the x coordinate is basically In this scenario, it's ln x. So ln of x is equals to 0. X is e raised to power of 0, which is 1. That is one thing. And what are we looking for? We are looking for the value of a. So either I can work this way, or I can plug in the value of ln x as 0 and the value of y as 1.3. So let me show you two ways of doing it. So method 1, that is working with line equation. So y equals to 1.3 and ln x, this value equals to 0. So therefore 1.3, that is 0. This is 1 over ln 3 multiplied by ln a. So therefore ln a is 1.3 multiplied by ln 3, and make a the subject, that is e raised to power of 1.3 multiplied by ln 3. Use a calculator and you get the answer as 4.17. That's one approach. What is the other approach? Method 2 is y is actually y. So therefore y is 1.3. Y is 1.3. ln of x is equals to 0. Therefore x is 1. That is shown over here like this. And now use equation of curve. So you can also work it out. So therefore x is equals to a multiplied by 3 raised to power of minus y. X is equals to a multiplied with 3 raised to power of minus y. X is 1, a is a, 3 is 3, and minus y is 1.3. And of course you have to use a calculator. Therefore you will find the value of a, which is 4.17, correct to 3 significant figures. So there are two ways of working this out. Let's look at the next question. Now the next question is about integration, and it's integration by parts. So let me write the formula for integration by parts. That is u dv, that is u v minus integral v du. So first of all, for integration by parts, a product is a must. So it's 1 multiplied with tangent inverse half x dx between the limits 0 and 2. What extra knowledge do I need over here? I need the knowledge that what is the derivative of tan inverse. So now this is something very common that is usually coming a lot in recent years. When we have y is equals to tangent inverse qx, and when we differentiate it, so therefore dy by dx, that is 1 over 1 plus qx, the whole thing square, multiplied by q. In other words, if y is equals to tangent inverse half x, so dy by dx should equal 1 over 1 plus half x, the whole thing square, and don't forget to multiply by half, just like chain rule. So therefore this is 1 over 1 plus 1/4 x square, and this thing is multiplied by half. If you want to simplify it further, I'll write this thing as 4 plus x square over 4 multiplied by half. Let me flip the fraction, that is 4 multiplied by half divided by 4 plus x square, which is 2 over 4 plus x square. So this looks neat and clean when I've done this on this side. Now let's start with integration by parts. So when we start with integration by parts, we have u, we have dv, we have u prime, we have v, and then we will follow the arrows. So u is equals to tan inverse half x, because we know how to differentiate it, we don't know how to integrate it, and dv is equals to 1 dx. So this is 1 and this is dx, this is your dv, and let me focus over here, this one is your u. So therefore du is already simplified, that's 2 over 4 plus x square. So 2 over 4 plus x square, and v is x dx. Now follow the arrows, this goes like this, this goes like this. So therefore this is x tangent inverse half x minus integral 2x over 4 plus x square dx. How will you integrate this part? 2x over 4 plus x square. Let me choose a different color. So how will you integrate this part? Now over here, let me explain it. This concept is if the numerator integral, if the numerator is the derivative of denominator, then the integral is ln of denominator plus a constant of integration. Is 2x the derivative of this? The answer is yes. So this is x tan inverse half x, and minus as it is, this is ln of 4 plus x square, and we don't need a constant of integration. The reason being limits are there, so this is 0 and 2. So that is the working. So far so good. When we have this thing, now let's plug in 0 and 2. So if I plug in 2, this is 2 tangent inverse 2 over 2. Half x is 1, and minus ln 4 plus x square, 4 plus 4, which is ln of 8. This is the upper limit. Minus 0 into tan inverse of 0, that is 0, minus ln of 4. So therefore this is 2 tan inverse of 1 is pi by 4 minus ln 8 plus ln 4. This is pi by 2, and this is plus ln 4 over 8. So therefore pi by 2 plus ln of half, that's one way of writing it. Have they specified any particular way? The answer is no. Or pi by 2 plus ln 2 raised to power of minus 1, or pi by 2 minus 1 ln 2. So this is definitely correct. This is also correct. This is also correct. So there are 3 forms of writing this particular answer. So this is question number 4. Let's look at question number 5. What does question number 5 says? So this is the variant, that is 32. Okay, so now question number 5, it says we have a complex number u, and it's given by 10 minus 4 root 6i. Find the 2 square roots. So this question has come after a long time. So therefore we will say that square root of a complex number 10 minus 4 root 6i. Square root of a complex number is another complex number which is a plus bi, where a and b are real. Exact, that will come up later. So that is the working for this particular part. And now what else does it say? It says that you have to solve it. So therefore 10 minus 4 root 6i is a plus bi, the whole thing square. Now expand this thing, that is a square plus 2ab I plus b square, I square is minus 1, so a square minus b square, that is the real part, plus 2ab, that is the imaginary part. This is 10 minus 4 root 6i. So let's focus on this. This real equals to this real. This negative 4 root x equals to this thing. So these are equality of a complex number. That is, the real equals the real, the imaginary equals the imaginary. First equation, 2ab equals to minus 4 root 6. ab is equals to minus 2 root 6. Therefore, make any one the subject. So if I make b the subject, that is minus 2 root 6 divided by minus 2 root 6 divided by a. That's the first equation. This was the orange equation, so let me highlight it. And then if I talk about the blue equation, what do I have? 10 equals to a square minus b square. 10 equals to a square minus 2 root 6 divided by a, the whole thing square. 10 equals to a square minus, this becomes 2 square is 4, 4 into 6 is 24 divided by a square. 10 is equals to 10a square equals to a power 4 minus 24. Therefore, a power 4 minus 10a square minus 24 equals to 0. Now you can make a substitution and let m equals to a square. Therefore, m square is a power 4. So therefore, m square minus 10m minus 24 equals to 0. 6 into 4. M square minus 6m minus 4m minus 24 equals to 0. M minus 6 minus 4m minus 6 equals to 0. Therefore, m minus 4, m minus 6 equals to 0. Let me double check. So you are getting two answers. This is a power 4 minus 10 squared minus 24. Now the thing is that this is minus 6 into minus 4, that becomes plus 24. Let me go back, because this is a very common error of middle term factorization that I just made. So this is m square, this is plus 2m minus 12m minus 24 equals to 0. That is the correct one. So m plus 2 minus 12 m plus 2 equals to 0. M plus 2 m minus 12 equals to 0. M is equals to negative 2. M is equals to positive 12. But remember, what is m equals to? M is equals to a square. So a square is equals to negative 2. Reject. Why? Because your answers are real. And similarly, m square a square equals to 12. Therefore, a square is equals to 4 into 3 square root. That's 2 root 3 plus minus 2 root 3. Now, a little bit more working is left. I can do the working on the right hand side. I think it's all messed up in the sense that in terms of space. So now the working is a is equals to plus 2 root 3. And then a is equals to minus 2 root 3. What is b equals to? B is minus 2 root 6 over a. B is minus 2 root 6 over a. And let me write it at the top. B is minus 2 root 6 over a. So this is minus 2 root 6 divided by a. So a is 2 root 3. So therefore, root 6 over root 3, the minus remains, and that becomes root 2. 6 over 3 is 2. That is the first thing that you get. The second one, let me highlight it again. So now this time b equals to minus 2 root 6 divided by negative 2 root 3. Negative cancel. That comes out to be plus root 2. Therefore, working towards the final answer. So final answer for the square roots, one answer is 2 root 3 minus root 2i, because the coefficient b is the coefficient of the imaginary part, and the other one is negative 2 root 3 plus root 2i, and therefore these are not conjugates, they have nothing to do with that. These are just square roots of a complex number. Now this thing is done. Let's look at question number 6. Now, what is question number 6 all about? It's a trigonometry question. It's like a proving identity. That is the first part. And the next part is about integration. And I think there are two parts to this. So 6a, 6b, there are two parts. It says prove that cosec 2 theta. So cosec 2 theta is 1 over sine 2 theta minus cot 2 theta, that is cos 2 theta over sine 2 theta. Let me thicken the pencil a bit. So this is 1 minus cosine 2 theta divided by sine 2 theta. Sine 2 theta is 2 sine theta cosine theta, which is the correct format for cosine 2 theta. That will cancel the 1. So that is 1 minus 2 sine square theta. This one cancels off. This negative cancels off. So therefore you are left with 2 sine theta divided by 2 sine theta cosine theta. Everything cancels, leaving behind a tangent. So that is for 3 marks, something very, very basic. Hence show that the answer for this integral is half ln2. So basically you have to integrate tangent theta d theta between the limits pi by 4 and pi by 3, and you should get this answer. So tangent is sine theta over cosine theta. Integral d theta. What is the derivative of sine? Derivative of sine is negative. Derivative of cosine is negative sine. So this negative is written. And in order to balance it, a negative is written on the outside. So this is negative ln cosine of theta. This is negative ln of cosine of theta. And it's between the limits pi by 4 and pi by 3. Now if you want to get rid of this negative sign, change the limits, change their places. So this is ln of cosine theta, and what goes up, pi by 3 goes down, pi by 4 goes up. So this is ln of cosine of pi by 4 minus ln of cosine of pi by 3. A cosine of pi by 4 is root 2 over 2. And this is ln, and this is ln of cosine of pi by 3, that is half. Minus means division, so therefore ln, and this is root 2 over 2 division 1 over 2. The 2 and the 2 cancel. This is ln root 2, which is ln 2 raised to power of half, which is half ln 2, and most probably this is the correct answer, which is exactly what I've gotten. Let's look at question number 7. What is question number 7 all about? Question number 7 looks like a differential equation question. It says a curve is such that the gradient at a point with coordinates xy is proportional to such and such. So dy by dx, that is equals to a constant multiplied by y divided by root x plus 1. So how do you end a proportionality sign? Multiply by a constant of proportionality. Now dy 1 over y dy, that is k, and this is x plus 1 raised to power of minus half dx. Let's first focus on this, that if the variable separable is all good. So this root x plus 1 is at the bottom. When you take it up, it has a minus sign, and I think everything is all good. Let's start integrating it. So an integration symbol is there. So let me put an integration symbol, a neater one, integration symbol. Let's start simultaneously. This is 1 over 1 ln y, k as it is. This is x plus 1 raised to power of minus half plus 1 divided by minus half plus 1. Don't forget the derivative of the bracket, which is 1, even though it's something very, very obvious, plus c. Let's first simplify it. So there are two constants, ln of y, minus half plus 1 is half, division by half is multiplication by 2. So this is 2k square root x plus 1 in brackets plus a constant of integration c. Now there are two limits, 0, 1 and 3e. 0, 1 and 3 comma e. Let me plug them one by one. When I plug in 0, 1, so therefore this is ln of 1 equals to 2 times k times square root of 1, because this is 0 plus 1 plus c. So ln of 1 is 0. This is 2k plus c, that is equation 1. When I plug in 3 comma e, so therefore ln of e, this is 2k and 3 plus 1 is 4 plus c. So ln of e is 1, 2k as it is, square root of 4 is 2 plus c. So therefore 1 is equals to 4k plus c, that is equation number 2. From the first equation, c is equals to minus 2k, 1 is equals to 4k plus negative 2k. So 2k equals to 1, therefore k comes out to be half, that's perfect. Therefore c is minus 2 into half, which comes out to be negative 1. So highlight the results that we have obtained. K is equals to half and c equals to minus 1. So now these are the two constants. Setting up, solving a differential equation, find the equation of the curve expressing y in terms of x. So now this was the equation, and now rewrite the equation with the correct constants. So therefore ln y equals to 2 into k is half, this is square root x plus 1, and c is minus 1. Let me simplify it further. That is square root x plus 1 minus 1. This is in brackets. This is ln of y. So now y is equals to e raised to power of this whole square root x plus 1 minus 1. You can write this thing as e raised to power of square root x plus 1 divided by e raised to power of 1, because if I do this step further, this is e raised to power of x plus 1 into e raised to power of minus 1, and that led to this particular format. So now this differential equation was pretty easy. A lot of extra space is given. Let's move to question number 8. So this is a full-fledged 8-mark question of differentiation, and it's about stationary points. Give answers correct to 3 dp where appropriate. So now this is product rule. Y is equals to e raised to power of negative 5x tangent square x, and the function is valid between the limits minus pi by 2 and pi by 2. U is e raised to power of negative 5x, and dv is tangent square x. Differentiate. This is not dv, my bad. That's overdose of integration by parts. This is v. That is u prime. This is minus 5 e raised to power of minus 5x. This is v prime. So this is 2 tangent x power 1. Derivative of tangent is sec square x. So now follow the arrows. vu prime, uv prime, something like this. So this is dy by dx equals to e raised to power of negative 5x, and in bracket we have 2 tangent x sec square x, and minus 5 e raised to power of minus 5x in brackets multiplied with tan square x. What can be taken common? Let me highlight what can be taken common. I can take e raised to power of minus 5x common, e raised to power of minus 5x common. I can take tangent common, I can take the tangent common. So there is a square, so take care of that. So therefore this is e raised to power of minus 5x, and let me take also common tangent x, and what's inside? From the first term this is 2 sec square x. From the second one this is minus 5, and this is tangent x. Double check it. So this is e raised to power of minus 5x. This is tangent x. This is 1 plus tan square is sec square. So I can have a complete equation in terms of tangent. So this is 1 plus tan square. So this is 1 plus tan square x minus 5 tangent x. So therefore this is 2 tan square x minus 5 tangent x plus 2. If I'm not mistaken, this is what I get. This is tangent x, this is e raised to power of minus 5x, this is dy by dx. Find the x coordinates of the stationary points on the curve. So what are these stationary points that we get? First of all, dy by dx equals to 0. And how many stationary points will you be getting? Let's see. E raised to power of minus 5x equals to 0. No solution. E raised to any power can never be 0. Any constant, any positive constant raised to power of 0, raised to power of anything can never be 0. No solution. Tangent x equals to 0. Sine x over cosine x equals to 0. Sine x equals to 0. So between this range, which is this, where is sine 0? So therefore x comes out to be 0 radians. So this is one answer that you get. Now you have this thing. So this is 2 tan square x minus 5 tangent x plus 2 equals to 0. I think it will factorize 2 tan square x minus 4 tangent x minus tangent x plus 2 equals to 0. 2 tangent x minus 2 minus 1, tangent x minus 2 equals to 0, tangent x minus 2, 2 tan x plus 1 equals to 0. So in other words, you have tangent x equals to plus 2, tangent x equals to negative half, and your this is in the first and second quadrant. This is in the not the first and the second, this is first and the third quadrant, and this one is second and fourth quadrant. The range is basically minus pi by 2 to pi by 2. So let me draw a small sketch on the side. What it means is that this is 0 till pi by 2, and this one is 0 till minus pi by 2. So let me first focus on this. This is the first quadrant, this is the fourth quadrant. So over here we'll be getting a fourth quadrant and a first quadrant. First quadrant would be anti-clockwise angle, fourth quadrant would be a clockwise angle. Got the idea? So therefore in the first quadrant theta is alpha, in the fourth quadrant theta is minus alpha, just like complex number. So therefore tangent of alpha is 2, alpha is something. Therefore theta equals to this alpha. Give the answer correct to 4 significant figures, then give the answer correct to 3 SF. That's the final one. Tangent of alpha equals to positive half. Here you will find the value of alpha. First write theta is something in 4 significant figures, then theta comes out to be 3 SF. So if the working is right, let me grab my calculator and let me just double check. So tan inverse of 2, so let me write it 2 and let me convert it into the radian form, and then tangent inverse. So this is 1.107, this one is 1.107, and then 0.5, and tan inverse, this is 0.4636, this is 0.4636, 0.4636, and then correspondingly you will get 2 answers out of this. So now it's all set, this particular question. That is question number 8. So what else is there? Extra space. Question number 9. Let's focus on question number 9. What does it say? It says express in partial fraction. I mean, this is too basic. This is partial fraction plus what? Integration or binomial? This is partial fraction plus binomial. So therefore this is 14 minus 3x plus 2x square divided by 2 plus x and 3 plus x square. Even before that, always check whether it's a proper or improper fraction. It's a proper fraction. So therefore we have first fraction, and the denominator is 2 plus x, and the other one, the denominator is 3 plus x square. What goes at the top? A linear factor. What goes on the second one? bx plus c in bracket, because this is a quadratic case. When we take the LCM, this is a multiplied with 3 plus x square and bx plus c in brackets multiplied with 2 plus x. And this is 14 minus 3x plus 2x square. And then there is a certain order in which you will proceed. Let x is equals to minus 2. So bx and c, it would disappear, and you will find the value of a. I'm not working this out, I'm just writing this step because people say it's too easy, so that's why I'm skipping it. Let x equals to 0. If this is equals to 0, so therefore on the left we have 14, and we have already found the value of a, which comes out to be 4. So 14 is equals to 4 multiplied with 3 plus 0 square, and bx plus c, that is 0 plus c multiplied with 2 plus 0. Correct? So 14 minus 12, that's 2. 2 is equals to 2c. Let me double check. 4 3s are 12. And this is 14 on the left. So therefore, when you find the value of c, the value of c comes out to be 1. Let's rewrite the equation again. So now we have of 14 minus 3x plus 2x square. This is identical to 4 multiplied with 3 plus x square and bx plus c. So therefore b is still unknown, c is 1, and we are multiplying it with 2 plus x. Now choose any other value. Let x equals to 1 and you would evaluate and you will find the value of b. The value of b comes out to be minus 2. Therefore, your final answer for partial fraction is as follows. A is the numerator of 2 plus x, so a is 4. So this is 4 over 2 plus x. And bx plus c, so b is minus 2 and c is 1. So this is minus 2x plus 1 divided by 3 plus x square. So this is 3 plus x square, and that is how this working is done. Now let's move on. What does it say? They are saying expand this in up to and including the term in x square. So this is binomial now. So therefore 1 plus b raised to power of n, that is 1 n multiplied by b power 1 over 1 factorial and n minus 1, b raised to power of 2 over 2 factorial, and this thing continues. So now in the first one, 4 over 2 plus x. Let me first focus on this. 4, 2 plus x raised to power of minus 1. 4 as it is, this is 2 common, 1 plus half x. The whole thing raised to power of minus 1. 4 as it is, 2 raised to power of minus 1. This is 1 plus half x raised to power of minus 1. So 4 over 2 is 2, 1 plus half x raised to power of minus 1. You need 3 terms out of this. This is 2, 1 plus minus 1 into half x. Power 1 over 1 factorial. This is minus 1, minus 2, half x, power 2 over 2 factorial. This is minus 1, this is minus 2, this is minus 3, this is half x, power 3 over 3 factorial, and then you can simplify it. So this is the first thing that I have done. That is the expansion of this thing. This is the first one. Let's focus on the next one. Minus 2x plus 1 or 1 minus 2x, 3 plus x square. So 1 minus 2x, and this is 3 plus x square raised to power of minus 1. 1 minus 2x remains as it is. This is 3, 1 plus x square over 3. The whole thing raised to power of minus 1. So let me focus again on this, on this. Over here, this power was on this and on this. So therefore, this is 1 minus 2x. That's a spectator for right now. This is 1/3. This is 1 plus x square over 3 raised to power of minus 1. And I think you just need one term because you need up till x square. So this is 1 minus 2x. And this is 1/3. And this is multiplied out. This is 1. And this is minus 1 into x square over 3 raised to power of 1 over 1 factorial, and you simplify it like this. Why do I write this plus and a dot dot dot? That means there are many terms. It's an infinite series, but we are stopping at this particular instant. So now this thing is basically this one. So therefore a working like this and a working like this. So now you would simplify everything and add it up, which I'm not in a mood to do because this is too basic of a math. Question number 10. This looks like a strong question of circular measure and then maybe something more. So let's see. It says the diagram shows a trapezium ABCD. So where is the trapezium? This is a trapezium. This is a line which is DC. Let me make it more thinner. This is DC. And there is another line which is this whole thing which is AB, and that's a trapezium, and there are two slants and they are not the same. Nobody's saying that they are the same. So let me just extend it a bit and a bit. There is this line, and let me draw a reddish one or a purplish one like this. Okay, so let me just. Now, first of all, what do I need? I need a vertical line. So let me drop a vertical like this. And let me label this A, B, C, D, M. So let me label this thing as Q. and let me label this thing as R. That's the first thing. Now, what do I need? If I focus on the triangle ADQ, so let me focus on this triangle. So that is this green line like this, and then there is a red dotted line like this, and then there is a bluish line like this. So this is A, and this is D, and this is Q, and this angle is X radians, this is R, this thing is R. So therefore if I use sine of X radians, that is equals to dq divided by R. So dq is R sine X. That's the first thing. Similarly, cosine of X is AQ divided by R. So therefore AQ, so this is AQ, is equals to R cosine X. These are the two things. Now AQ plus QR plus RB. Let me add one more thing. AQ plus QR plus RB. That is basically R plus R. But what is AQ? AQ is R sin X. And what is DQ is R sin X. Wait a minute. We have, I don't need DQ. And since it's the same length, it's an isosceles triangle. So RB is also R sin X. Got the idea? This is R and this is angle X. And this is R and this is angle X. Therefore, these two sides are equal. So it is isosceles. So therefore, write a QR over here. And this is equals to 2R. Therefore, QR plus 2R sine X is equals to 2R. Therefore, QR is 2R minus 2R sine X. That's the first thing. Also remember, since the sides are parallel, so QR is the same thing as DC. QR is the same thing as DC. That's also one thing. What else is there? It says area of trapezium, area of sector. So now I have, let me just create some more space, and that is what you have to think in the exam, that you should create more space beforehand. So this is something like this, and let me remove this thing on this corner, and let me just grab this thing, something. Now what else is there? I can find the area of trapezium. So area of trapezium, that is half sum of parallel sides. Parallel sides are DC and AB. So this is DC plus AB multiplied by height. Height is DQ. Height is DQ. So therefore this is half. Sum of parallel sides is DC. DC is the same thing as QR, which is 2R minus 2R sine X plus AB. What is AB? AB is 2R. Bracket closed, multiplied by DQ. DQ is R sine X. My bad, this is R sine X, and I think I made a small mistake. That AQ was R cosine X. So let me correct it. This is R cosine X, this is R cosine X, this is R cosine X, and so on and so on. So I'm just getting this thing corrected. This is R cosine X, R cosine X. That was this one. This is R cosine X, this is R cosine X, and this is cosine X. Okay. Now can I simplify something? I can. This is half. And this is 2R plus 2R, that is 4R minus 2R cosine X multiplied with R sine X. And this is half multiplied by this. So it will multiply with only one bracket, that is 2R minus R cosine X multiplied with R sine X. Leave it as it is. That's the area of the trapezium. What else do I need? I need the area of the sector. So some of the areas of the shaded sector. So area of sector, let me call this thing as AMD. That is half r square theta. That is the same thing as area of sector BMC. BMC. Therefore, total shaded, that is r square x, because it's 2 times this. Now the area of shaded sector is 90% the area of trapezium. So area of shaded is 90% area of trapezium. So therefore Rx, r square x actually, r square x is 0.9 multiplied with 2, and let me take r common out, and this is 2 minus cosine x multiplied with r sine x. I think the final time has come. This is r, this is r, this is r square. So you are left with x is equals to 0.9, 2 minus cosine x multiplied with sine x. Is that the answer? Yes, that is the answer. Now it says verify by calculation that x lies between such and such. So make an equation out of this. F of x is x minus this whole thing, 0.9, 2 minus cosine x multiplied with sine x, bracket closed. Make sure your calculator is in the radian mode. So let me just write it. So calculator in radian mode. Plug in f of 0.5, evaluated. Plug in f of 0.7, evaluated. There will be a change of sign, and that change of sign would prove that the root alpha lies between 0.5 and 0.7. This is the root of the equation. The next part is continuation of this. It converges to the root of the equation in part 1. So now there are 2 approaches to this. Let's see whichever one is convenient, we will do that. One approach is show that, first of all, let me read it. Show that if the sequence of values given in the interval is given by the iterative formula, then it converges to the root of the equation in part A. So basically, either take part A and show it equal to the part C, or the other option is take the part C thing and make it equal to part A. Part A is equation, part C is iterative formula. Got the idea? This thing is the iterative formula. Part C is the iterative formula. Make it equal to the equation. So if I take the equation, that is x minus x is equals to 0.9 and such, x is equals to 0.9, 2 minus cosine x into sine x. And what have they done? They have made the equation in such a way that there is a cos inverse. In other words, cosine of x is such and such. So make cosine of x the subject. So therefore, x divided by 0.9 sine x equals to 2 minus cosine x. Cosine x is 2 minus x over 0.9 sine x. Is that so? Yes, something like this. Therefore, x is cosine inverse 2 minus x over 0.9 sine x. And then on the left hand side, write the subscript n plus 1. On the right hand side, write n. And this is how you show the conversion from equation to the iterative formula. What about the other one? Iterative formula to the equation. So x bracket n plus 1 is cosine inverse 2 minus xn over 2 minus, this is xn over 0.9 xn. Now the thing is, after successful iteration, your input becomes the output. So that is why this thing and this thing and this thing, they all mean the same thing, they disappear. So your equation is x is equals to cosine inverse 2 minus x over 0.9, and this is sine of xn. So let me just make this correction. This is 0.9 and this is sine of xn, and let me highlight it with a red because now it's gone. and this is sine of x. Therefore, cosine of x is 2 minus x of 0.9 sine x. And then cosine of x minus 2 is negative x over 0.9 sine of x. Multiply by minus throughout. 2 minus cosine x is equals to x over 0.9 sine x. Make x the subject, that is 0.9 sine x multiplied with 2 minus cosine x, and that is the equation. Maybe the terms are forward, backward, they are changed or swapped. Now, what does it say? Use this iterative formula. Where is the iterative formula? Xn plus 1. So now we have xn plus 1 is cosine inverse, and this is 2 minus xn, 2 minus x subscript n, 0.9 sine of xn. Now this takes some time. It's easy, but it takes some time. Now what happens is that when you do the working for this particular part, you have to do successful iteration, and where do you stop? That is the golden question. First of all, since the root lies between 0.5 and 0.7, so let me choose x1 as 0.6. That is the first thing that I'll focus on. That's the first value. Therefore, let me plug in the calculator. Radian mode is a must, otherwise your question would go wrong. That is 2 minus 0.6 divided by 0.9 sine of 0.6. Of course, it's in radians, and don't forget the cosine inverse. So therefore, let me shift this a little bit over here, and let me shift this thing over here, and this thing is cosine inverse. And then this value comes out to be, I've already calculated, this is 0.6106. So x2 is 0.6106, x3 comes out to be 0.6151. And then move on, x4, this is 0.6170. Move on, x5 is 0.6178. Now stop and think for a second. Usually it takes 4 steps. These two answers, 1, 2, 3, they are getting closer and closer. They are asking us to work in 4 decimal places so that the final answer is 2 decimal places. So let's round off and see. This becomes 0.62. This becomes 0.62. So even if I've done something extra, don't worry, your answer is safe and secure. So the root of this equation is 0.62, because successful iteration means your input and your output value is exactly the same. So even if you go any step further, it doesn't make a difference. Now this looks like the last question. Let's see what's in there. So now the question says, with respect to origin O, the points A and B have position vectors such and such. So it's not a 2-dimensional vector. One of the term is missing. So this is 2, 0 and minus 1. The K 2, minus 1 and 0. So this is 2. J is minus 1. K is 0. Similarly, what is OB? OB is I is missing. That is 0, and then it's a 1, and then it's a minus 2. Show that OA modulus is equals to OB modulus. That's something very simple. OA modulus, that is 2 square minus 1 square, 0 square, under root, which comes out to be root 5. OB modulus, that is 0 square, 1 square, and negative 2 square, square root, that is also root 5. So you have to find AOB. Just show some working. That is like this and like this. This is A, this is O, this is B, and take 2 vectors diverging from a point or both converging to a point. So OA dot OB, that is OA modulus, OB modulus cosine of theta. So this is 2 minus 1 0 dot product with 0 1 and 2, 0 1 and negative 2, that is root 5 cosine theta, and they want the answer in degrees. So let me just highlight it a bit more. So therefore you have to multiply it this way, and then multiply it this way, and then multiply it this way. So therefore this is one number. Let me write it in order over here. over here, over here. And therefore this is 2 into 0 is 0, plus minus 1 into 1 is negative 1, plus 0 into minus 2 is 0, divided by root 5. Root 5 is cosine theta. Are they asking for the acute angle? They are not saying anything. So therefore theta will come out to be cosine inverse of negative 1 over root 5, and it will come out to be obtuse. So let me grab the calculator and let me evaluate it. So therefore this answer comes out to be 101.5 degrees, correct to 1 decimal place, because that's written at the beginning of the paper. Okay, next part. The midpoint of AB is M. So let me first write the midpoint over here. So I'm just doing some working for the next part, but on this side. So therefore OM is half of OA plus OB. A lot of people, they think otherwise. Let me show you the mistake. So a lot of people, they think that OM is half of AB. This is totally wrong. This is totally wrong. Why? Because half of AB could be, let me write it like this. So half of AB, if I draw a line like this, let me draw a line, hold for a second. So this is A, and this is M, and this is B. So half of AB could be AM, or it could also be equals to MB. This is correct, but this thing is totally wrong. This thing is a misconception. Best way is OM is half of OA plus OB, that's half. What is OA? 2 minus 1, 0, 2 minus 1, 0, plus 0, 1 and minus 2, 0, 1 and negative 2. When I add it up, half of 2 is 1, half of 0 is 0, half of negative 2 is negative 1, that is OM. And what else are they asking us? OM is 1, 0, minus 1, 1, 0, minus 1. It's passing through O and M. It's passing through O and M. Therefore, R is equals to something plus lambda something. So OM is the direction vector 1, 0, minus 1, and the origin is the fixed point. M could also be the fixed point, but I've chosen the easier version. And what does it say? There is a point. So P is a point on the line. So therefore OP is just the extended form, that is lambda, 0 and minus lambda. So simple. Such that PA is to OA. So PA is basically OA minus OP. What is OA? OA is 2 minus 1, 0. So OA is 2 minus 1, 0, minus OP, which is lambda, 0 and lambda. So you get this thing over here, and then you have PA is 2 minus lambda, minus 1, and 0 minus lambda is minus lambda. This is PA. And PA is to OA is root 7 is to 1. What is OA? OA you already know, that is 2 minus 1 and 0. What is the magnitude of OA? Magnitude of OA was found earlier, that is root 5. And let me also do one more thing. Let me shift it down and let me write magnitude of PA, because I'll be needing this. So magnitude of PA, that is 2 minus lambda the whole thing square, and minus 1 the whole thing square, and negative lambda the whole thing square. When you expand it all. So this is 4 minus 4 lambda plus lambda square. This is plus 1. This is lambda square. So therefore this comes out to be lambda lambda square, that is 2 lambda square. And this is minus 4 lambda, and 4 plus 1 is 5. And don't forget that there is a square root at the top. So let me write the square root with a red symbol, so that it's a little bit obvious, something like this. So now let me move this thing over here. Let me move this thing over here, and let me thicken it. So something like this. Hold for a second. This is square root. This is square root. This is square root. And there is a square root on top of this thing. Now what does it say? The ratio of PA is to OA. So this is PA magnitude. This is PA magnitude. OA magnitude is root is to 7. So magnitude of PA divided by magnitude of OA is root 7 is to 1. In other words, PA magnitude is root 7 of magnitude of OA, which is root 7 multiplied with root 5, which is root 35. So that is also done. So now 2 lambda square minus 4 lambda plus 5. 2 lambda square minus 4 lambda plus 5 is equals to 35 because the square root disappears. Let me write it. And then let me make it the subject. So 2 lambda square minus 4 lambda minus 30 equals to 0. Lambda square minus 2 lambda minus 15 is equals to 0. Therefore 15 is 5 into 2. So lambda square and then minus 3 lambda, actually plus 3 lambda minus 5 lambda minus 15 is equals to 0. Lambda plus 3 minus 5 lambda plus 3 equals to 0. Therefore lambda is negative 3. Therefore lambda is positive 5. What am I looking for? I am looking for the possible position vectors of P. So let me write down 2 options. This is one option. This orange one is the other option. When we talk about the blue option versus the orange option, so the blue option is OP is this thing, lambda 0 minus lambda, that is minus 3 0, that is minus 3 0 plus 3. That makes sense. And when we talk about the orange option, that is 5 0 minus 5. Are they asking us in any particular format? Possible position vectors of P. This is perfect. Or you can write OP is minus 3i plus 0j plus 3k, or OP equals to 5i plus 0j minus 5k. So therefore these are the 2 possible answers for this particular question. And luckily we are all done with May-June 2021 variant 32. That's a P3 paper.